it's up to the accuracy of around 2 centimeters if we are using a very particular GPS. So basically how it happens is the photogrammetry is a very known technique. It has been used from decades. It phased out because the resolution which was available was not useful. Now the same technique is now scaled up. I mean, you have brought down the altitude and increased the resolution and accuracy because of the miniaturization of the sensors. So when we let's say specify the user interface that this is the area I want and with this resolution. Let's say I'm looking for 3 centimeter per pixel resolution, for example. What does it mean that I can look at any object which is of the size of 3 centimeter on the ground? So based on that information and the accuracy requirement, the algorithm will compute that how many images I need for each and every feature on the ground. So let's say, for example, I have a small feature I need to look at 5 different angles so that I can compute the three-dimensional feature as well as the measurement. So based on that algorithm, where each and every image has to be captured will be computed first. And then what is the optimum path for computing those or collecting those images will be required. And the drone trajectory has to follow those parameters. So it's all a very accurate flight which enables this. So if you miss your orientation as well as the position of image collection, the accuracy will be hampered. Sorry? I'm not getting your question. Sorry? Yes.
Are ground-based.
Ground-based, yes.
In the sense, if
yes.
somebody wants to the precision in height from the ground level.
Yes.
If you want to take
it's in the different coordinate system. You can change the coordinate system. So conversions, transformations can be always done. So the basic data is always in the global coordinate system. So you can always bring it to your local coordinate system and can be, I mean, see, whatever points are visible, they are having certain coordinates. It doesn't matter what reference system you have used. If you are talking about ground, then it's a relative measurement. So you can always measure that what is the difference between this level and that level.
Seems.
So just for example, how the industrial inspection drone works and what kind of use cases we are exploring in India. So one of the use cases is around the solar power plants. So there are enormous number of solar power plants in India, and there are enormous number of them which are going to come in next couple of years. And there have been mandate to put a facility of 10,000 megawatt plus by the government. Now these solar power plants have to maintain certain output to generate revenue. And for that, the entire plant should be running at a particular level of efficiency, which is again driven by the health of the panels which are installed. So if the panels are not generating enough electricity, the company or the entity will be ending up losing the revenue. The government will be ending up losing the power. So to be able to make sure that there is no fault on the field or in the whole farm, which is maybe 100 megawatt ranging to 1000 megawatts, we used to do manual assessment, which used to take days, and there was again error scope in that because a person used to do that manually. So it really depends that how the person thinks, how it operates, and whether he is in fatigue or not. That is the best thing which machines deliver. There will be no fatigue if you operate them properly. So this is one of the use case where a drone very quickly can capture the hotspot, which means that that particular panel is running at lower efficiency and generating higher heat. Such panels can be very quickly identified and can be located in the entire farm, and a very statistical measure can be taken by the agency that how much replacement do they need to do in the field. And it also helps them to keep on maintaining their particular output. So what are the possible outputs with the drones today? You can get realistic 3D models for your visual as well as statistical analysis. Again, very specific point cloud data, which I again skip. It's more specific to the civil engineers. The elevation models, contour maps. You can always get aerial videos from very generally available drones. You can get vegetation indices, very real-time vegetation indices to take very accurate information about the farmland. You can get thermographic outputs to make sure your industry is running at par the efficiency level. So just imagine we have lakhs of kilometers of power transmission lines running across the country, with thousands of towers, power transmission towers, which are very high and very difficult to reach. Now today, how they operate is they shut down the entire line. They send a guy up, which is like 70 feet above the ground, and he inspects all the infrastructure there and gives a report that this is damaged and that is damaged. So it depends on his assessment, first of all, his understanding of the situation there. Second, the safety measure is always there. And then you're cutting down the power and you're basically losing revenue, both the power generation industry as well as the normal consumer is losing power. So that's where the shedding happens most of the days. So with the drones today and the advanced technologies which has come in, you can basically investigate such infrastructure without making any person to take that risk, without losing any specific information, as well as cutting down the power, losing the revenue as well as the comfort of your public. So as a company, what kind of business model we are working on? So see, for the enterprise sector, what we see, this is a beginning. This is the beginning of the commercial market. So drones have seen a very good growth in the DIY sector and then consumer sector where people have been using it for their own luxurious and videography purposes. Now, in terms of industry, it's not about just collecting the image. It's about how you extract the information and how you drive the information out of that data. So that is where we are playing a role, and that's where we even show the light to the entrepreneurs in India, that India has been a source for most of the software services. And drone industry, since Chinese companies and US companies taking dominance here in terms of hardware technology, because they have initiated their activities at least 5 years before us. It's a good opportunity for us to get into these analytics solution where a drone as a hardware and such analytics and intelligence can be put together and can solve very precise use cases. So as a company, we deliver the complete suite of solution to our customers. We supply the drones, which are intelligent enough and accurate enough to collect the smart data. We also provide them facility to process their data, which again needs a different kind of infrastructure. And if required, we also deliver analytics, which is right now very limited to particular use cases, not very wide spectrum. Now, looking at the industry as a whole, so in skipping the just specific applications and talking about our company, if you look at the, in a nutshell, that where the drone industry is heading, the first thing which has happened in the drone in last 2 years is the autonomy. And that autonomy has changed the whole game. So the piloted drones, we can see the cost of using a piloted drone was really very high, which came down, which was even higher than the manned aircraft. So most of our military drones were piloted drones. They were not fully autonomous. So with this, let's say, intelligence capability developing and the sensors coming down to very low cost, autonomous drones have increased. And this is where these use cases have emerged because of the autonomous drones. So going further, the more autonomy we develop over the drone, the larger will be the scope. So if you look at the example of DJI and others, as well as what Intel is doing, the entire focus is on autonomy. And that autonomy only drives the decision that what direction the hardware has to be developed. Because to deliver more autonomy, you need more processing and more sensors to come in. And that is where the hardware development is being driven. So it's autonomy which is driving the whole show in the drone industry. Now, the three major waves which has taken in the drone industry in last decade. The first was the DIY, where the consumer drone people were buying separate parts and putting them together and flying drone for their fun purposes, college workshops, as well as a lot of open source projects were there. Now, after that, companies like DJI emerged, which made the drone like any general equipment in your bag and made it very easy to operate. That's where the consumer era took place. And last 5 years, that has been the era where more than a $5 billion industry was created out of that application. Now, the current era is of the consumer drone. This is what is going to be the 5 years, because in the commercial applications. Next 5 years is to be for the commercial applications, because what we have observed in the consumer drone, people get bored with capabilities and stuff which are too high. Let's say smartphones, it has become very common thing for everyone, and it's very monotonous for every one of us. We don't really use all the apps which are installed in our phones. But if we see the regular uses of apps, there are apps like Zomato, there are apps like Ola and Uber which are being used. Those are the apps which are making our life easier. So those are the cases, again, where the drones are able to make the life easier for the industries. And that is why the commercial drone applications are picking up. So if we talk about the technical evolution, so where we stand today, we have reached a good stage in terms of communication systems, GPS integration, data processing, and sensors. Companies like Intel, Qualcomm, everyone working towards that direction has enabled the things to be available at very, very cheap rates. The mid-range is in terms of obstacle avoidance techniques, where a couple of companies, only limited companies like Intel and DJI has been able to develop something really practical. Manufacturing techniques, we have seen a lot of 3D printing. So the drone there itself is half 3D printed and still has flown more than 100 flights. So the availability of smart materials and smart technologies has enabled companies like us to not go into large-scale production, and still make workable units at very low cost. So advanced engine and lighter weight structure carbon composites now are available at very cheap rate from Chinese market. So we are at the early stage in terms of smart battery technologies. The batteries are still very, very less energy storage capacity. Technologies like the gentleman discussed about the solar panel integration is still in the very early stage. We don't have that efficiency solar panels available for general users like us, wherein we can integrate very easily at low cost with the drones. High efficiency solar panels are limited to space grade applications, and companies, giants which own the patents, still not available at cheaper rates. So what's the forecast of the industry? Basically, the highest growth which most of the market research agencies are forecasting is in the commercial sector, which is 32% plus compound annual growth. Largest market being driven by the countries like US, Europe, countries in US, and then the following countries are going to be Asia Pacific. Still in terms of drones, the Asian Pacific countries are still lagging behind, especially India. The kind of problems which we have and the kind of scope which we have not yet explored 1% of the application from the drones, which countries like US have started already doing it. So there is a potential for very strong growth for both indigenous industry and use cases and market in India. But it is on hold because of certain reasons in terms of adaptability of the technology by the industries. Second has been a lot of role has been played by the policy itself, which has slowed down the whole industry in last 2 years. So these are some of the largest growing sectors: the inspection and monitoring, precision agriculture and mapping and surveying, followed by entertainment, education, retail, and prosumer drones. I'll skip the details, and then let's talk about the domestic market. So Indian market still at a stage where none of these research firms have yet mapped our commercial capability. Most of them have been mapped for the defense industries. And surprisingly, we are the largest importer of drones in the defense industry. We import more than 22.5% of the entire world's defense drones purchase. That's the world's largest. Followed by Dubai, countries like Dubai, UAE, which are very rich when compared to India. So the projected market is around 420 million in the defense. So we can always use this data to track that how much potential will be available for the commercial applications in drone. Of course, the variety of applications and the extent of uses is much larger to the defense when compared to general use case of surveillance. Now, since Sumanth has already covered in detail about the regulation, what exists and what are some terms, I will rather like to put our personal observation about the regulation rather than going very specific about what is there. Anyone can read that draft in the public, it's public actually. So we were very happy as a startup when DGCA decided that they are going to frame a regulation, because that was a very, very progressive step. In US, that step was taken when almost 10,000 users were using drones on daily basis. Here, we were having hardly 100 to 150 such users active every day. But what it came with a ban saying that you cannot use for consumer applications. We will be bringing out the draft in, let's say, another couple of months. We expected that since the government is saying couple of months, it might be maybe a quarter or let's say 6 months. After 2 years, after a year or so, there was a draft which was issued for public comments, and after that public comment, still the guidelines which were promised to be released in 2 months have not yet seen the day of the light, and I'll say rather the dawn, because they have not been yet passed to the further authorities. And meanwhile, like we missed our opportunity in many of the industries, tech-driven industries, we lost the market to China, which was not even having this mandate back in 2014. It brought that mandate in 2015, and in just a couple of years, it has issued more than 10,000 plus pilot licenses, driven a import revenue of 1.5 billion plus from the local drone industry, supplying drones to the market like US and India. And the largest manufacturer of drone and the most advanced technology emerged from a company which is again China-based called DJI. So it has been a very good opportunity for India to at least catch up in the new emerging company, because we missed the opportunity when the smartphone revolution was taking place. Now we are pulling the companies back to India so that by luring the consumer power which we have, which is not a right strategy according to me. So what the draft is missing as a whole. The draft is missing a speedy process. So if we just run through the draft asks the procedures to be followed, which itself will take 3 months for an operation of 2 days. And there is no global harmonization. So if a developer like us wants to develop some technology based on the regulatory requirements, we cannot make a technology which is applicable for India as well as the foreign territories. So there is no harmonization between what other agencies are doing for other countries and what we are thinking for India. There's a huge gap between the knowledge about the drones and the technology. That's where platforms like NASSCOM can play a very big role in basically sharing the right knowledge with the concerned people. Uh, with our discussions and participation in the whole regulatory affair, what we have found out that the authorities are still missing the vision of Digital India and Make in India, and are really concerned about some hypothetical safety and privacy concerns, which can be tackled technically rather than in using very extensive procedures. So it has almost like become a license-driven industry. So how these concerns can be solved? These concerns can be solved by making the whole thing inclusive rather than exclusive. What we need to do is we need to focus on technologies which can share more data about the drones, make people more responsible about their activities rather than asking them to follow procedures. So I'll just share one use case what happened with us. One of the large PSUs in the mining industry wanted to use drones to find out some problem in their mines. So they ended up basically running behind various, it's a government organization taking permission from a government organization, forget about the private people. They kept on running behind government organization for 3 months to take a permission, and it took 2 days for us to finish that task. So for a 2-day task, they have been running behind the authorities for 3 months. So when we are talking about drones, we are talking about the factors like cutting down the time, increasing the flexibility, cutting the cost. It cannot be delivered unless the procedures are really synchronizing with what the machines are able to deliver. So at a last, as a motivation factor, I'll say what we believe in our company, that a great nation cannot be built with a borrowed technology. So we really need to empower the local industry in terms of innovation, not only manufacturing. Thank you. Any questions?
Thanks for the session, Vipul. So you're talking about the different applications of the drone, right?
Right.
Is there any application or situation where this has been used for a natural disaster or an emergency response kind of thing?
Yeah, there has been a couple of use cases. So again, they range from variety of data. One application has been during the Uttarakhand floods, wherein drones, again by one of the very famous startups called Idea Forge, which was started by IIT Bombay graduates, was used for identifying people who were stuck in different small locations. Similarly, during the Nepal earthquake, a lot of companies voluntarily jumped in. Unfortunately, we were not having our product at that point of time. So they mapped the entire area, and still there are a couple of proposals lying with the ministries wherein drones have been used to identify quantify the damage. So during Chennai flood, the Chennai airport was damaged, and the drone was used to map that area very quickly and identify the efforts which are required, and to make sure that the runway is healthy enough to make emergency landings.
Yeah, so this is not only for probably looking at the airport, maybe like the places where people cannot travel, right? Especially if you're taking the Chennai floods, right? Maybe dropping the packets of food, or probably going to the nearby houses and see where exactly what is the situation about. So is there anything of those kind of things where
Situational awareness, yes, they have been used. I mean, they are being used from a very long period of time. Situational awareness about the traffic, situational awareness about the wildlife, encroachments, as well as emergency situations. For situational awareness, they have been used in India from last at least 4 or 5 years. When we talk about various other applications in terms of, let's say, finding out the efforts to be required to re-establish that area, or quantifying the damages, these are very new use cases. Couple of use cases exist in India, but not very extensive.
Yeah. So one more, so whenever we say UAV drones, we only think of something traveling in air, right? Is there any UAV which can travel in air, water, and land? Do we have anything of that in a combination of all the three?
See, when we talk about such capabilities, no, there are a lot of parameters which come in together. So there are companies which are trying to do something which can be built, but the let's say the structural parameters and the intelligence which is required to work in all three, it makes maybe you can develop a prototype with the current state of technology which is there, but making a full-fledged practical application is still a difficult task. So couple of companies are there which are working in that direction, but still not reached a stage where a practical application can be derived.
Thanks, Vipul.
Any further questions? Okay, so basically when you approach them, I mean anyone approaches them, there is only one standard statement: we are working on it. So it's like there are three different, if you want to go in detail, there are three different organizations which are working on it: DGC, MHA, and DOD, Department of Defense. There are certain people who have been given responsibility to give their concerns. So when you talk to one guy, he gives the hat to the other one. When you go to the other one, he gives the hat to the other one. It's like never-ending loop. So that's what the responses are.
I just wanted to know what is proprietary about your company? What is your IP in this? Because everything else is available online.
Like?
If you go into mapping, you can find algorithms and everything online on GitHub. All your drones are available online. You can build a drone on your own. So what is exactly proprietary about your company?
See, the flight controller to structure design, everything is proprietary here. When we talk about the open source projects which are there, they're good to learn. But when we talk about the practical applications, the reliability and the accuracy which they deliver on, let's say, consistency as well, that's not which you can implement practically. You can do a couple of flights and maybe generate a 3D model, but if you want to really measure them accurately, you need to improvise on all the in all the directions. So for an example, let's say I give you a mind of a monkey and a body of an elephant. It won't work, right? So it has to work in parallel. So mind of a monkey thinks in a way how his body work, and then only he jumps, right? So if you really want to solve a problem, if you want to jump from one branch to other branch, you need to have all of them together. Right claws, right body, right mind, right intelligence, right sensors. So that's one of the USP, putting all of the right things together so that they can seamlessly, without any problem, any reliability issues and consistency issues, can deliver you the results, desired results. Second is that the intelligence which works in almost all these open source projects is at a different level, and when you really sit down and look at those projects and you want to do some practical application, you will end up either investing years into cleaning those codes, or you'll find it more comfortable to write your own, right? So that's where the difference is, to get that reliability and consistency and accuracy which is required to solve those problems with performance which can sell. So I cannot sell a drone which looks good, performs everything, but flies only for 5 minutes. I need to be competitive enough to get that 30 plus minutes of flight time so that a user in a Go can map, let's say, 100 hectares of area. If he is not doing that, his return of investment is not there. So to be able to do that, I have to optimize my propulsion system, sit down on the motor winding as well, that the current motor windings which are available for consumer sector, as you said, online stores. You won't get any motor which is 80% plus efficient. When you calculate, you'll find that you need 95% plus efficient output. For that, you'll again have to sit into the design as well as the material change. You might not be doing everything yourself. You might get to a vendor who's smart enough to fulfill your requirement, but you should be smart enough to know what you need. So that's where, to know how what is required to solve a problem is the USP here.
Assume that there is a closed environment like building, multi-floor building, and assume that GPS is available throughout that building. Uh, Barely, okay.
You don't have a GPS, let's consider.
Oh yeah, within the building. So can we plan the path of this drone within the building with available GPS?
See, GPS signals, practically GPS signals, if even they are available in the building, there are a lot of issues with multipathing and all, wherein the GPS positioning will not be accurate. You really need a different technology for that. a real-time positioning technology will be required, which can assess the area and then generate the trajectory. As a company, we haven't yet reached that level, but yes, companies like Intel do have in their portfolio such technologies, wherein you can real-time map the building as well and define the trajectory and fly within the premises and map the area. So
No,
yes,
just bare minimum. Assume that there is a door in the first floor, there is a window, and fifth floor there is a door. Just a bare minimum path with.
how do you know what is behind that door? Let's say you don't know the building structure. You open the door and there is a column which has broken down. Someone needs to take a real-time decision that I don't have to barge into that column. I have to take a different trajectory. So the GPS signal really doesn't work in that way. It will only know the position of the drone globally, not inside where the building structure is, how the building structure is, where are the columns, where are the sofas, where are the table lamps, and where are the staircases. These are the things which are not available to the drone. So that has to be done either through image processing or different techniques, which again, a couple of companies have been able to do, but not again at a very practical level, still in the exploratory level. But what we believe in a couple of years, that will be also there in the market. So to precisely answer, if you're looking at commercial application, it's not going to happen in next 2 years.
No, at some point of time, as a prototype, you would work on a sample, right? In the sense,
Sample.
Yeah, in a sample environment where you won't consider a real-time complexity.
Mm-hmm.
So assuming bare minimum